Welcome back to Build Propulsion Lab at Swiss Cloud Native Day. And my next guest is Natalie Godec. Welcome.
Hello, thank you for having me.
And Natalie, she's a speaker in the event, of course. And you mentioned that your talk was about Terraform, best practices, and what not to do. We called it worst practices.
Yes.
So, all right, let's start with the worst practice you can do with Terraform. What's like the absolute terrible idea?
The absolute terrible idea is probably to approach your infrastructure as you would as a software engineer, meaning thinking about describing your infra as a flow of procedures, as opposed to describing what you actually want.
All right, okay, wait a second. I remember vividly how Liz Ford Jones, when she explained what SRE mean, claimed that SRE is when you approach your infrastructure as it was software engineering.
Right.
So,
So differences, subtle differences. And I always see that because people come to the world of DevOps and the world of like platform engineering. A lot of them come from software engineering or like back-end engineering specifically. And then they come and say, oh, can I manage my infra in Java? Please don't. You know, it's a little bit of a different concept. You need to think what your end goal is and then describe it. And then, yes, we approach it as software engineers, but in the sense that it is reproducible, it's versionable, it is code that is stored in your GitHub, GitLab, whatever repo you have. But at the same time, it is not a list of procedures to be called. No, you are describing, it's a configuration language, it's a descriptive language. You describe, I want a Kubernetes cluster and like a bunch of VMs and a bunch of IAM policies, and that's for the system, for Terraform in this instance, to figure out how to do that, which APIs to call in which direction and in which sequence. It's not up to you to say, do this, then wait, then do a local exec, then wait, and then do that. No. You just describe the whole state.
that makes sense. All right, okay, so it's similar in the infrastructural approaches to software, like it's versionable and it's you can refactor it.
Exactly.
But you need to describe the final state of what you want to achieve instead of doing it procedurally.
Yes.
All right.
Yes.
Okay. Excellent. Okay. What would be the absolute best practice of Terraform? What like everybody should start doing tomorrow?
You need to start thinking about your infrastructure as a platform. And always, when you are writing whatever, always think about what will happen in 6 months, a year, 3 years from now when you're gone and someone needs to maintain it. So it needs to be understandable, it needs to be as simple as possible, and it needs to be maintainable. So when you're writing your Terraform modules, try to make them abstract. When you're writing your variables, try to make them in a way that they have defaults where it's necessary and where it makes sense. And some things are optional, leave them as optional. And maybe, just maybe, you're writing your Terraform module in a way that the inputs that the end user will give are minimal. Like, okay, I need a Kubernetes cluster, name, region, size. That's all. Maybe that's all that needs to change. Everything else is in defaults. But also at the same time, you're exposing that everything else. So it's kind of like modules that are very flexible and structured in the same way. That's maybe another thing that I would mention. Try to structure all of your modules and environments in the same consistent manner. So you don't have hard-coded values in one place and variables in another place. Everything needs to follow the same pattern so that A, someone needs to maintain it, they will be able to maintain it. And B, when you are needing a new module or a new piece of infrastructure, you can look at the existing stuff and write a new one in the same way, and everything stays consistent.
Love it. Great. Okay, now what will be the best practice for Terraform? Like, again, the absolutely best thing to do in terms of security. Like, if you need to name one thing that everybody should definitely do, what that will be?
Use Chekhov.
Use
Chekhov. Yes.
Okay.
It is, so not Chekhov, like Czech, OV, but a play on the name. It's an open source tool that allows you to either use community defined policies for security or define your own policies. And basically, what you can do is integrate it into your CI/CD. So you open a pull request or a merge request, checkoff runs automatically on all of your Terraform code, and checks for known misconfigurations. Open ports, public IP addresses, open policies, admin on the organization, those sorts of things that the whole worldwide community has already thought about. It's like, it's not OPA, Terraform compliance will be OPA for Terraform, but checkoff is just so easy to integrate into your CI/CD. You just take it, add the command, the step into your CI, done. It already checks it for you.
Nice, love it. How about managing secrets?
Yeah.
That's like obviously a big topic, and there are tons of best practices of how to do it and how not to do it. And probably in the world of Terraform, Vault is kind of the default. Is it as simple as just like use Vault, or there are other ideas that people should embrace?
Depends which secrets we're talking about. Vault is obviously one of the use cases. If you can use Secret Manager from whatever cloud provider you have, that's great as well. Terraform itself has resources for generating secrets and passwords, which you can pass the output directly into where you need to pass the secret to. If we're talking about the password for the default user of a database instance, you can generate that password and it will be passed directly, into the resource, and it will not be stored. Those generators can be marked as sensitive so that it's not in the output. You can store the state in a bucket that you restrict access to, so that people cannot go into the Terraform state and see what's inside the state. And I've seen people try to use KMS to encrypt a value that then is passed into somewhere else. Maybe it doesn't need to be that complicated. And maybe if you are, for example, using a secret manager, does the secret need to be written in Terraform? Or maybe you have a team that can do that initial writing of the value of the secret into the secret manager. Just like in Vault, someone needs to write it in Vault.
Exactly.
So maybe you don't need to have a KMS key that will encrypt the secret and do it in Terraform. Because what happens when you need to change the value?
Yep.
Someone will need to change the value anyway, and then you have a Terraform drift and that sort of thing. So think about using the Terraform generators where possible, or data lookups where possible. And if you do need to, then Vault or GitHub Secrets or Secret Manager, tools like that can help as well.
Beautiful. All right, let's talk about another terrible idea of what not to do.
Terrible idea of what not to do. Managing too many resources in the same state, I would say, is an anti-pattern.
Okay.
And too many, I'm talking 2,000. Or if you had, one of the examples that I had in my talk was managing all of the database instances of your environment in the same state. It's okay if you have 3, but what if you have 3,000? Maybe not 3,000, but 300. It's very typical to have hundreds of microservices, each of which needs a database. If you're on AWS, the tiny instances are super cheap, so people usually go with a database instance, an RDS instance per microservice. And you end up with having 350 database instances managed in the same state, and you have 10 environments. How do you debug all that? And what happens if your module is broken? Now you have 300 database instances that are broken, and teams from all of those microservices are trying to make changes to the same state. That becomes very difficult to maintain.
So what will be a good pattern for organizing resource management?
Yeah, so if you do have microservices, each of which needs a certain number of resources, and those are different teams that are managing those resources, then they will not have an infinite number of things they will want to deploy. They will maybe need a bucket, a database, a bunch of IAM roles, some topics, some KMS keys, maybe. Okay, then you create a service module where you instantiate those kinds of resources, types of resources that are available for developers to deploy on their own. The inputs, again, you make them very flexible, everything optional. and so on, and then you give that service module into the hands of the developers of each application. Now, each of those teams manages only the resources that they are responsible for, and they are self-service. They are happy, they don't need the platform team, they don't need to call you and open a pull request and wait for someone to approve it. They can just self-serve, and with things like owners, Git owners on like within the Git repos, you can even make sure that each team has the approval request, merge request need to be approved by the members of that team. You then need GitHub teams or GitLab teams or whatever your repository system is, but you structure that in that way, and then it's in the hands of the developers. And they have a list of resources that they can deploy. They cannot go wild. So you're happy, you're at peace that everything that's going on in your system, you know, and you've managed the modules, you've provided them with the security defaults, you've provided them maybe even with the CI/CD pipelines. But they are also happy because they can self-serve.
So this again, we're back to basic software engineering principles, right? You have the common module that then particular modules or services reuse, and this common module is servicing multiple other modules.
Yeah.
Beautiful. All right. Today we learned, Natalie, that was insightful.
Thank you
Very much. And thank you all for watching. And stay tuned, we have even more interviews of Build Propulsion Lab at Swiss Cloud Native Day. Stay tuned after this. Natalie, thank you for coming.
Thank you for having me. Bye-bye.